Hello, everybody. I'm excited to be the last talk between you and your happy hour. But until then, I'm going to send you happily into the happy hour by telling you about all the dollars you can save on Grafana Cloud. And I'll be joined up here as well by Marl Settler. He's one of our engineers on the Mimir squad. Come on down. Intro, I'm from Miami, Florida, known for beaches and retired people. I am not retired, still working hard here at Grafana Labs. A little overview about the talk. I'm going to kind of frame the problem of cost management, how we as a company are thinking about that. Then we're going to do a deep dive into two exciting features that we have on the metrics and log side. And then I'll wrap it up with a what's next. So first, as many of you in this room are probably well aware, adoption of observability is happening faster than ever. I stole this from the CNCF 2022 survey, and when they surveyed the adoption of their technologies, they see that open source monitoring and observability is kind of growing the fastest of all the categories. As an observability company, this makes us very excited. We love to preach about all the great things that we believe observability can bring to an organization that's trying to deliver great experiences for their customers. Now, unfortunately, there can be shocks when people adopt observability kind of in a rush, right? Everyone's rushing to realize these wonderful benefits of observability, but when you roll this out in a hurry, you're not thinking about how you do this. You've got kind of everyone rushing to the door who may not be an expert in how to use it. You can sometimes be a little bit surprised. And in fact, we've run our own Grafana Labs observability survey. It's still open if you would like to take it. And we saw that 71% of our respondents so far cited that some of their biggest concerns about adopting observability at their organizations are costs, unpredictable bills, and lack of visibility into what they're spending. Now, what we don't want is people, speaking of that cute little dinosaur thingy, people pulling the plug on observability, giving up on it because they got burned by costs, right? That would be a very sound outcome for us. So how do we go about solving this problem? Well, interestingly, we've actually seen this same sort of problem cycle happen in the cloud provider space, right? Everybody is excited about cloud. Many of you maybe finished your move to the cloud. You might be 10 years into your 3-year cloud migration. And people moved because they believed there were all these benefits of going to the cloud. However, as people did that, some of them were shocked by how much they were spending, right? They maybe weren't seeing the benefits they expected at the cost they were willing to pay. And the cloud providers, though, were smart. They saw this happening and they responded. They realized that successfully adopting the cloud means doing so in a way that's sustainable for your business. And to make that happen, they invested. They built a bunch of tooling themselves to help you manage your spend with them. This is a screenshot of the Azure Cost Explorer, AWS Cost Explorer. I wouldn't be surprised if people in this room have probably used these UIs before. And so we at Grafana Labs have been doing the same thing with observability. Now, I would certainly hope that your observability bill is less than your cloud bill. We can talk, if it's not, we can help you. But similarly, we don't want people to abandon observability. We want them to adopt it in a way that feels sustainable, in a way that what they're spending feels proportional to the value they're getting. So we too have been building our own feature set for managing your spend on Grafana Cloud. We started with cardinality management dashboards to identify the highest cardinality metrics in your environment. We've added usage groups for tracking different label sets, those cardinality over time. And we've talked at length, you're probably tired of hearing us talk about it, about adaptive metrics. But what we noticed so far is what we had provided was a bunch of different features. And it's been up to you to figure out which is the right one for what particular job you want to do. And we realized we needed to take a pause, and instead of just throwing a bunch of features over the wall at you, we needed to do a little bit of organization of them to make them more accessible to you. Because I do not expect you to memorize every single feature with every silly name that we come up with and know how to use it, right? So we thought through what it is that someone cares about when they're trying to manage their costs. And we kind of sorted it into these 4 major categories. The first things you want to do are kind of inspect your costs, break them down by the vectors that matter to you. You might want to do some attribution, figure out which team it is that's responsible for what fraction of the costs. Some folks are looking specifically to reduce their bill, and others are actually comfortable with their spend right now, but they want to be alerted in case that ever were to increase. So what we've done is bring everything together into what we're calling the Cost Management Hub. Now, Tom touched on this a little before. This is less of a new feature and more of a organization of the existing features we have. So now as kind of a first-class citizen, live in your Grafana Cloud account right now, you can drop into cost management and see all of the different features organized by their function for optimizing, analyzing, and monitoring your costs for metrics and logs observability. And with that, I will pass it to Mauro to talk about my favorite tool in the cost management toolkit, adaptive metrics.
Thank you. Hello, everyone. My name is Mauro. I'm a software engineer at Grafana, and I'm one of the people who are working on adaptive metrics. Here you can see some other important personal information about me. I have a 1,746-day language learning streak on Duolingo. Gracias. So anyway, I'm here to talk about adaptive metrics, actually. So let's talk about that. So adaptive metrics is a feature that consists of multiple different components, and I'm going to be talking about those components roughly in the order in which you as a user are going to experience them if you use it. So it all starts with analyzing your usage and your metrics. So we have a job which fetches your dashboards, it fetches your recording rules, it looks at your recent queries, and it also looks at the metrics that you ingested. Based on all of that information, it then identifies labels that raise your cardinality and which you do not use in any of your queries. Now you have to keep in mind that cardinality means that they raise your active series count, and the active series count is what you're paying for. So we are looking for labels that you pay for and which you do not use. Based on all of that, it then provides recommendations, where each recommendation will say something like, we recommend that you drop the label X and aggregate the underlying series by some aggregation function. And the recommendations are sorted by the potential gain, where the potential gain is defined as by how much you could reduce your active series count if you apply the recommendation. There is also a UI to show that and to interact with it. This is the overview page where you can see the status and some tips and tricks. And then in the recommended rules tabs, you can see the recommendations. So there is one recommendation for each metric. And beside each name, there is a series impact, where the series impact shows by how much you could reduce the active series count if you apply the recommendation. I'll now open the first one, the node CPU seconds total there. And you can see some more details. So in this case, it says that it recommends dropping the label CPU, because apparently we didn't use that, and aggregating the underlying series with some counter and count. I'm going to explain more in detail what that means in a moment. It also shows you some other usage stats that the analyzer job has found. And you can see that there is an apply recommendation button, so I'll hit that now. And with that, it's going to be in the applied rules. So when I hit that apply recommendation button, the UI took the recommendation and it turned it into what we call an aggregation rule. And it posted that aggregation rule into our API, from where it then got propagated across our systems. Once that aggregation rule is applied, every time when we receive a sample, we are going to look at the aggregation rules, and we are going to decide whether this sample needs aggregation. And if so, we send it to an alternative service that we call the Adaptive Metrics Aggregator, which then processes it. Oops, sorry. So I've talked a lot about aggregating series now, and I'm going to explain that a bit more in detail. So first of all, why do we need to aggregate? Because if we just drop a label without modifying anything else, we end up with fewer series, but some of them are going to be just a mixture of many other series. And we are not going to know where each data point comes from, so they lose a lot of their informational value. To preserve the informational value, we need to aggregate them with an aggregation function, such that the informational value that we want to get out of the metric gets kept. I'm going to show how that works with an example now. So let's take that same metric again, the node CPU seconds total. By the way, this is a counter which counts by how many seconds each CPU core spends in each of its modes. This is a simplified example. Here it has the metric has a cardinality of only 4. You can see that there are 2 labels. Each label has 2 possible values. And now let's say we decided that we want to drop the label CPU and aggregate by count for the sake of the example. So what we do is we take those series and we drop the label CPU, and then we group them by matching label sets. So we put all of those which then have the same label set into groups, into one group. And in this case, we have 2 groups where each group has the same label set. Now we need to aggregate each of those groups. So in each group, we will perform the aggregation function, which in this case is a count. You can see that the result is 2 because each group contains 2 raw series. That 2, the aggregation result, then gets stored in an aggregated series. In this case, it would be node CPU seconds total _ aggregation count and so on. So this is a simplified example, but it shows how it works. And important is that we are going to generate this aggregated series, and then we are not going to store the raw series. So this is how we help you to reduce your active series. Now, looking at this strange aggregated series with the extra special label, you might be wondering, am I going to have to rewrite all of my dashboards and my queries for them to still make sense? The answer is you don't, because we have also modified our query handling in such a way that when we receive a query, we can see that there is an aggregated series to serve that query, and we're going to take that value and then process it and transform it in the correct way to return the same result, no matter whether the metric has been aggregated or not. So the aggregation is transparent to the person querying the metric. I'm going to also show that with a practical example. So you can see 3 panels here. Let's first just focus on the top one, the first one. In this one, I'm doing a count on node CPU seconds total. So this counts how many series are in that metric. In the beginning of the time range, it keeps returning the value 24,000, because apparently there are 24,000 series inside that metric. Then I apply the aggregation rule, and there is a 5-minute gap there. Actually, we still try to get rid of that 5-minute gap, but at the moment we need it, because we basically, during that time, we swap out the underlying series. So we stop ingesting the raw series and we start generating the aggregated series. But anyway, after the 5-minute gap, it keeps returning the same result, because at that point the query handling realized that, okay, there is an aggregated series and we need to use that aggregated series and use the value correctly in such a way that we return the same result. So then let's look at the second panel. I'm querying the same metric again, but in this case, I'm doing a sum of rates on that metric. Now, this demonstrates 2 things. So first of all, it keeps returning the same result again, and it's possible so this demonstrates that it's possible to do multiple aggregations on each metric. So if you think back to that example where we generated an aggregated series for each group, with multiple aggregation functions, we will then generate multiple aggregated series for each group. And at the time when the query gets handled, we select the right one and use that data to serve the query such that the aggregation is transparent. This also demonstrates the sum counter aggregation function that you saw earlier. When in the recommendation, there were 2 functions, count and sum counter. So sum counter is a special aggregation function to some counters, as you might have guessed. The reason why counters need a bit of special handling is because they can reset at arbitrary moments in time. So if we would just sum those values together, there might be random drops that will make the metric less useful. So we need to handle those decreases due to the resets correctly. And you can see that it works because it keeps returning the same result again. Now, the last panel is very important. That shows the billable time series. So basically, that represents how many time series you get charged for if you store that metric in our system, in our cloud. In the beginning, it shows 24,000 because that metric has 24,000 series, right? Then when I apply the aggregation rule, there is a significant drop in it. Now I would like to point out that in this last panel, the vertical axis starts counting at 0. So I didn't do this funny trick where I will start counting at a high level just to make the decrease look big. But so that's not what's happening. So this is the actual decrease that you will see in your build in this example. Now I've been looking at I've been talking about the typical use cases where you would apply a recommendation, but there are also some more advanced use cases. First of all, I would like to clarify that. So these recommendations that we generate, they are supposed to help you to find the labels that you might want to drop, but they are not limiting you. So you can define your own aggregation rules, post them into our API, and you can decide to drop any label that you want to drop. You're not limited by the recommendation. If you do that, it's also useful to use prefix and suffix matching, because you might want to apply the same aggregation rule to multiple metrics without having to write it for each metric. So you can prefix and suffix match on the metric names. And we also support keep labels rules. So previously, I only talked about rules where you would specify which label you want to drop, but you can also specify which label you want to keep, and then all the others get dropped. So that's the inverse logic. Then I would also like to point out that there are 2 more upcoming features which we are still working on. They're not released yet, but they should be coming soon. One of them is auto-applying recommendations. So that sounds pretty simple, but it's a bit more complicated because we want to also give you some control over under which conditions that the recommendation gets auto-applied or if which criteria are met. And also, we are going to support partial metric aggregations. What I mean by that is that we are going to support dropping a label only on a subset of the series of a metric instead of dropping it on all of them. So that's useful, for example, if in your organization you have multiple teams which generate the same metric, and some of those teams say that they're fine with dropping label A, and some other teams are not fine with dropping label A. So we want to make it possible to drop the label A only on the series of that team, which is fine with it, and not dropping it on the series of the other team. And that's it from me. I'm going to give it back to Jen.
All right. Thanks, Mauro. All right, so we've focused primarily on metrics so far because this is where we've heard the most pain. And we've been able to do a pretty good job so far with very, very cheap logging. But that only gets you so far, right? And especially as more and more companies are putting all of their observability spend under the microscope. So with that, I'm very excited to announce that we kind of have our first dedicated feature for understanding your logs costs, which we're calling the Log Volume Explorer. And I'm going to take you through a demo to help you understand what this feature is meant to do. So let's say you come into your Grafana Cloud account, you land on your home page, and you see, okay, I have ingested 633 gigabytes of logs so far this month. Now you see that number, and you might want to understand, okay, great, where is that coming from in my environment, right? You might want to break that down into pieces because you might have some intuition about where those logs are coming from, and you want to say diff your intuition against that number. Maybe you want to break that number down by team and then say, hey, interesting, team A is 50% of my costs, team B is 25%. Now, how would you do that? With the Log Volume Explorer, you can drop into our Cost Management Hub, you can drop into our Logs Cost Management section, and then you can jump into the Log Volume Explorer. You land on kind of this handy-dandy overview page that's going to give you the basics, but then you drop into the meat of the feature. Now, you start by selecting a time range. In this example, I'm going to select, I want to look at my log volumes over the last 30 days. That's a typical billing period. Then you pick which label would I like to break down my log volume by. This can vary from company to company. In my example, I'm going to pick cluster. Let's say I want to break down log volume by Kubernetes cluster. And then you just hit submit, and you can now see volume over that 30-day period broken down by each value of cluster. So in my example here, I see that the majority of my volume is coming from that SE demo cluster, and all my other Kubernetes clusters are actually quite a bit smaller in terms of volume. All right, so if you were looking to optimize your logs costs, you would probably start with the SC demo cluster because that's where the majority of your logs are coming from. Let's say you want to drill down one level deeper. How about within the SC demo cluster, which namespace is the one that's driving the majority of the volume? Well, simply add one more filter. And here again, now you're going to see within that cluster, what is the breakdown on a per namespace level? And what are you going to see? Well, in my example here, the development namespace is driving the majority of that volume, and the production namespace is then the next largest. So maybe that was a surprise. Maybe you would have thought most of your logs are coming from prod and not dev. So this is basically helping you drill down in a very point-and-click way to do that first level of analysis of your log volumes. And since you're billed by volume of logs ingested, this is directly giving you insight into your costs. And before, the way you would have had to do this is you write your own log QL queries, maybe you write some recording rules. Now you kind of have this point-and-click UI. We also have the ingestion rate over time view. This is really helpful for looking at sort of sudden spikes in log ingestion. So maybe you wake up one day and you're opening your log volume and you're like, hey, it's sort of surprising that seemingly overnight my log volumes have gone up. And so here you can see, pick a label. In my example, I picked app, and you can see these ingestion rates over time by value. I have gotten behind my video. So I am going to, can we advance to the next slide? Can we? If not, I can just keep talking. All right. So that was kind of a brief overview of the Log Volume Explorer. It's going to let you break down volumes over time. It's also letting you see ingestion rates over time if you want to see where maybe a sudden increase in log volume was coming from and where it started, like on what particular day. And that's going to be, for us, our first look into exploring log costs. If I go through kind of at a high level everything we covered today, we started with the announcement of our cost management hub, right? Bringing all of our cost management features together. Mauro talked to you about adaptive metrics, which moved into general availability, and a couple exciting things we have coming next there. And I talked to you a bit about the Log Volume Explorer, which we are announcing today in public preview. Now, all of these things are all live in your Grafana Cloud accounts. So I would love for you all to give them a try, share some feedback with us. We're relatively easy to find. We'll be around and always available on the Slackverse. And next slide, please. And I would just like to say, we're very much not stopping there. I now have a cost management toolkit, so I want to keep shoving it full of really cool and exciting tools. As Tom alluded to in our keynote early today, we are actively developing several other tools for our observability cost management toolbox. I believe he dropped the adaptive logs teaser, shall we say, still in research phase as the product manager. I have to very much say, not yet ready to be sold, sales team. But we are hard at work on it. We are looking for customers who are really interested to partner with us in that early development. And I think we're going to have some exciting announcements about it this time next year.